Hello everyone. So this video is about function definitions. So you'll be able to define what a function is, and then you'll also be able to find and confirm that a function is an inverse. The first part is, what is a function? A function is any set of x's and y's, or inputs and outputs, where the domain matches up with the range. So the domain means that it's all the sets of inputs. So it's usually just the x values. It's called the independent variable. So the range is the set of all the outputs, or the y values. It's a dependent variable. So a function is a set of these x's and y's where for each x there's only one y. So for each element in the domain, that's paired with only one element in the range. So going through the first example, the domain would be all those x values, -1, 0, 1, 2, 3. The range is -5, -3, -1, 1, and 3. Okay? If there's any repeats, then I wouldn't write them. Now, because there are no repeats in the x, this is a function. Okay? But in our second example, the domain is 3, but the range is 1 and 5. So literally 3 would be 3, 1 and 3, 5. There's 2 3's in there. So this is not a function because the 3 is paired with 2 outputs, or paired with 2 y values. Now, I can also do this on a graph. If a graph has a shape like this, like a parabola, then if I draw vertical lines to check to see if it crosses, or the x values, you'll see that these vertical lines only cross the graph once. So therefore a graph can be said to be a function if vertical lines only cross once. Now, if I change that, and let's say I put a loop in there like this. Now, if I draw those vertical lines, the vertical line only crosses once down here. But then when I get to the middle, I draw this vertical line, it hits here, it hits here, and it hits here. It hits more than once. That means that this x value is paired with 3 y values, which means it's not a function. So I can, on graphs, I can do what's called the vertical line test. If I can draw a vertical line, and that vertical line only hits it once, then it's a function. If I can draw a vertical line and hit the graph more than once, then it's not a function. In these problems, all you're going to be doing is listing out the domain and range and telling if it's a function or not. Remember, if the x values are repeated, then it is not a function. Now we go into inverses. You might think of inverses as like solving an equation. So the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of squaring something is square rooting. Functions have inverses too. So if we take this first function, f of x equals 1/4 x plus 3, we're going to determine the inverse function. So the first step is to take that f of x and change it into y. So I'm just going to write it y equals 1/4 x plus 3. Then I switch the x and the y. Okay, I just swap them. Now I solve for y. So I'm going to subtract 3 on both sides. I get x minus 3 equals 1/4 y. And then, because it's 1/4, I'm going to multiply both sides by 4. I'm going to be left with 4x minus 12 equals y. This is my inverse. You see that I swap the x and the y. Now I'm going to graph if needed. In this case, I'm going to graph. So I'm going to graph both of those functions. So the one in red is my original, the one in blue is my inverse. You see that they cross, and they cross at 4, 4. They should cross on a point that's along the y equals x line. So that point where they cross should be the same number for x and y. In this case, the y equals x line is that yellow line, and it crosses at 4, 4. So I know that I did this right. So for these 3 practice problems, that's all you're doing, is following those 5 steps, graphing them, and then confirming that they have an inverse. Now, the reason why they cross at the y equals x line is that they're actually reflected over that line. And we're going to go through more of the reflection pieces with the quadratic and the logarithmic. But they should always cross at that y equals x line. So we use that to verify inverses. So to verify an inverse, we're actually going to check if they match up at that y equals x. So the first step when I'm verifying is that I substitute one function into the other. You might call this composition. So I'm going to take the g of x, I'm going to plug it into the f of x. So all I did was I took this piece right here and I plugged it in right there, okay, in place of the x. Now I'm going to simplify the expression, so combine like terms. So the first thing I'm going to do is I'm going to multiply the 2 times the 1/2. I'm going to x plus 7 minus 7. Then I'm going to cancel out those 7, and I get just x. The third step is I'm actually going to take this next function. I'm going to take this f of x, and I'm going to repeat the process, only I'm going to plug it in here. Okay? So I take one, I plug it into the other, and then I reverse that. So I took that 2x minus 7, I plugged it in for x. I then simplify. Okay, so the 7's cancel out, and then 1/2 of 2x is 1x. Now you see that they both simplify down to x. Alright, if they both simplify down to x, then the two functions are inverses. So in this case, they are inverses. Okay. Now, for my second example, I repeat that same process. Okay. I took this function here, and I plugged it in there. And now I'm going to simplify. So I'm going to do 4 times the 1/4 x minus 3. I'm not going to multiply this by 4 because it's outside the parentheses. I then am going to combine the -12 and the 1/3, and I get 11 and 2/3. Now, this did not simplify out to just x, so these functions are not inverses. So I can stop right there. Once I get something that doesn't simplify down to x, I can stop right there. So those are not inverses. So these practice problems are just confirming if they're inverses or not. Please complete these and come in with any questions. Thank you.